means that my velocity, or excuse me, my position time graph is going to have it's going to be pretty deep. So let's see, what do I want to use? What do I have left? I should probably use all of them. Let's count. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oof. 24, 25. We'll do 25 boxes, and that gives me 10 per box to go the 250. So 10 per to, what is that, 190, 170, 150, 130, 110, 90, 70, 50, 40, 30, 20, 10, 0. And then we want still 7. 1, 2, 3, 4, 5, 6, 7, because our time in the horizontal and in the vertical is the same. So this is my scale for my velocity time graph. Excuse me, my displacement time graph. Vertical displacement. And it's in meters. So I know that at time 0, I'm at 250, right? So my first one should be down here. And I know that at time 7, I'm going to be at 0, right? So I know that I'm going to be at 0 down here. So we need to figure out at time 1, time 2, time 3, where is my position? So we're going to use this same equation. We're just going to plug in 1, 2, 3, 4, 5. So y is equal to 1/2 times negative 9.8 times 1 squared. That gives me negative 4.9. So if I started at 250 and I went negative 4.9, my new position is going to be 255.1. So over 1, 250. No, excuse me, 245.1. Right there. And we're going to do this for the whole time. So 1/2 negative 9.8 times 2 squared. 4, so 2, so that is negative 9, what is that? 19.6. So 250 minus 19.6. My position at time 2 is 230.4. 230.4. All right, we're going to do this for the whole thing. So squared. So I think that's 44. Let's find out. No. Yep, 44.1. So after the 3 seconds, I've been displaced negative 44.1. That leaves me at 205.9. So at time 3, I went up 205.9. Negative 9.8 times 4. Let's see what that is. Negative 78.4. So 250 minus 78.4 gives me hey, can you guys keep it down? 171.6. So I'm going over 4, up 71.6. And I got 2 more at time 5 and at time 6. So at time 5, so negative 122.5, 250 minus 122.5 gives me 127.5. So my position at time 5 is 127.5. And then my last one, I ran out of room. I'm just going to do it up here. 1/2 negative 9.8 times 6 squared. Gives me 176.4. 250 minus 176.4 gives me 73.6. There. All right, so we have a nice parabola shape. We can connect our dots here. And this is going to be our vertical displacement time graph for our lunch pail that was in free fall. So let's do our velocity time and our acceleration time. My velocity time is going to be negative because I started with no velocity. So and let's figure out our final velocity here. I know I have none initially, so my final velocity is equal to my initial velocity plus acceleration times time. My final velocity is going to be equal to negative 9.8 times 7. Gives me a final velocity of negative 68.6. So I know my scale has got to be like at least 7 deep. So negative 10, negative 30, negative 40, negative 50, negative 60, negative 70. So at time 7, I'm at negative 68.6. So this is going to be a straight negative line. So at time 1, using that equation, your final velocity is equal to your acceleration times time. Right? We are able to figure out what my velocity is at time 1, at time 2, at time 3. Right? So the first one is going to be negative 9.8. The next one will be negative 19.6. Negative 29.4, negative 39.2, 49 even. Then what is, I forget this one, 6 times 9.8, 58.8. There, all right. So this gives us a straight line. And then the last one, after 16 minutes, is our acceleration time graph. Time in seconds. Your acceleration, meters per second. This is velocity, meters per second. All right, and this is just going to be the negative 9.8. Right, we have a constant negative acceleration at negative 9.8. All right, those are the graphs. So this was for problem the 7 and 8 from yesterday. I'm going to have you do a different problem. Hopefully you can use this as an example. Let me know if you want me to do another one or if you have any questions.